A sphere is inscribed in a cube that has a surface area of 24 square meters. A second cube is then inscribed within the sphere. What is the surface area in square meters of the inner cube? So if I were to draw the diagram, this is the outer cube and then there is a sphere inside it. So this is not a very good diagram. It's a badly drawn diagram because it doesn't show all the edges. So if I were to draw the edges of the outer cube, you can probably realize how this sphere is sitting and where it is touching the walls of the cube. And since it is touching the walls of the cube, so if I were to draw the diameter of the sphere, it would be equal to the length of the side of the outer cube. So then I drop in this inner cube, and if I were to draw the diagonal, you see they would touch from end to end, they would touch the sides of the sphere, and this diagonal would be equal to the diameter of the sphere. And so if you draw the center, and if I said AB is the diameter of the sphere, that would also be equal to the side length of the outer cube. That would be equal to CD. So this will help us, understanding this will help us to solve the problem. So then CD is a diagonal of the smaller cube. O is the center, I already said that. And then I join CE, and then I get CE is perpendicular to DE, which is obvious because CE is a diagonal again. If there was a complete diagram, because there were too many lines, it'd probably be confusing. So I didn't know how to do it other than draw, which is again not really a straight line. So anyway, C is perpendicular to DE. So then we move on to find the lengths of the sides. So surface area of the outer cube is 24, and this would give us that the side is 2 meters, so side is 2, side length would be 2 of the outer cube. And then if that, so that would be also equal to CD equals AB, so that would be 2. So now we move on to the side length of the smaller cube. We assume that it is A, and therefore we can say that CF is equal to FE. It's a cube, sides are all equal, that would be equal to A, and we can write CF square plus FE square is CE square using Pythagoras theorem, because this is a right angle. The edges CF is perpendicular to FE, the edges are all right angles, not edges, the vertices, sorry. Then we have, if you write, then we can write CE square. So CE square would be equal to A square plus A square, so that's 2A square. And then DE is also equal to A, and so then CE square plus DE square is equal to CD square, and therefore 2A square, because CE is 2, C square is 2A square, so 2A square plus D square, A square is 2 square, because we know CD is 2. So we can write 3A square is 4, so hence A square is 4 out of 3, and so the side square of the smaller cube or the inner cube is 4 out of 3. So therefore the surface area of the inner cube would be 6 times 4 out of 3. So the answer is 8 square meters.